Hello and welcome to DevOps Canada Summit. My name is Micah Block. I am a data architect at DataStax. DataStax is the company behind the open source Apache project Cassandra. Data architects at DataStax are pre-sales technologists. And I have been working for DataStax for the last 2.5 years and have expertise in databases, cloud, APIs, and DevOps. And thank you for joining me today. And today we're going to talk about why database as a service is DevOps Best Friend. So what we're going to talk about today is, first and foremost, what are the challenges that DevOps face in regards to databases? We're going to do a little bit of primer as what is database as a service and why would I want to use one? I'm going to use an example of a database as a service specifically around DevOps, and that database will be DataStax's Astra DB, which is a database as a service based on Cassandra. And at the end, I will go through a demo of some of the features of Astra DB and how it relates to DevOps. So the first part is, so what are the challenges that DevOps faces in regards to databases? So this is one of my favorite quotes. We cannot solve our problems with the same thinking we used when we created them. This is from Albert Einstein. As we are, and how that relates to databases, as we all know, data continues to double every 2 years. So that in itself has created greater challenges in the database world in general, but more specifically in DevOps. How do I, as a DevOps engineer, manage these databases? This is based on IDC's Global Sphere 2021, and obviously it's going to continue to grow. And you'll notice a couple things here. A lot of the data is just replicated database data, so there's different ways to look at the data, and hence it's being replicated. What we also see here, and this is not noted in this chart specifically, but while many people talk about the growth in the non-structured data, there is still a lot of structured data that's going around in the world. In many cases, it's IoT data. We all use our devices. There's a lot of data associated with this. So there's both structured growth in both structured and unstructured data. The digital era is upon us, so there's definitely a need to transform how we're doing our business in general, but and especially around databases. Part of it is the digital volume from the different devices, but we're also talking about a data-driven distribution and data-driven decision-making within our processes. And then there's also a lot of AI-enabled experiences. You want recommendations. All this is requiring businesses to transform how they're doing things. Part of that transformation is getting better and more efficient in regards to databases. So one of the things that are more new in the database world is NoSQL. So what is NoSQL? This is just a very short primer. It is simply, it's a kind of a loaded term. All it means is that it's a not only SQL database. There's a lot of different forms of NoSQL databases. There's graph databases, there's wide column, key value pair, document databases. Really all it means is it's not a SQL databases. But some of the characteristics of these NoSQL databases is that they're not necessarily designed around SQL. Typically, NoSQL databases are designed to use in cloud applications. They're designed to use massive amounts of data in real time. They overcome some of the challenges with relational databases. So relational databases, typically, the way the way they scale is you just get a bigger machine. They're typically single node machines. They have ways to shard data, but essentially they're really around scaling by getting bigger machines, where typically NoSQL databases are distributed databases by nature, and the way you scale is you just add additional nodes. And there's a lot of things around NoSQL databases that really are designed to be high performant. So what are the typical database operations that we actually have? So, and this is where the DevOps kind of comes into play. There's stuff on the hardware itself. So if you're doing self-managed databases and you're having your own data center, then there's hardware management, there's power, cooling, rack, all the things that you have to do with the hardware itself. And then there's the information around the operating systems, the database software, the database creation, the database maintenance and backups and restore. And then there's the data, then that's just kind of maintenance on the database. And then there's the day-to-day operations. I need to do continuously performance tuning of my database. I need to do health monitoring. I might need to scale up or scale out my database as it grows. I need to make sure it's compatible with different applications and different databases. So these are the type of operations that typical engineers have around the databases, and DevOps has to take care around all of it. So kind of like the way we see the challenges that DevOps engineers have with databases is configuration and tuning, scaling up and scaling down, and so I might need to increase. Typical example is we're coming up to, or we're in the midst of it, at least October, November, December type of retail, where I have I need to scale up all my databases during that period, and maybe I want to back it down, scale it down when the holiday period is over. There's backup and recovery. I need to constantly back up my database. I need to test the recovery. I might need to upgrade my database. I might need to upgrade the hardware the database is running on. I need to monitor the database to make sure everything is running smoothly. I need to do all that. And obviously all this has to be around in a secure environment, so nobody can hack into my database. Only the people who have privileges to see the data actually see the data. So that's just kind of an intro as to what are the challenges when it comes to a database. So now we're going to go into and talk about what is a database as a service and why would I want to use that, right? So what is a database as a service? Really what it means is just run my database for me, right? That's really what it means. So it typically includes the software to run the database, the infrastructure that you need to run the database, the operational tasks that we talked about before, the upgrades, the maintenance, the backups, all that is done for you. And that is what a database as a service. So basically, think of it as all the benefits of a database with none of the operational overhead. So why would I want a database as a service? It's easy to use. All right. Typically, all you need is an endpoint for your application. You connect your application to the database, you're up and running. Typically, it's faster time to value because it's so easy to start. Typically, you could get a faster time to value, a faster time to actually build my application, develop my application, and then run my application. The other part to that is typically there's a fairly significant total cost of ownership benefit when it comes to running a database as a service, mainly because I don't actually have the ops. So there's a lot of benefits that I have from a cost perspective, that there's a lot of less of overhead from a personnel perspective to operate the database, but typically also it requires less resources. So it's even just the database software versus a database as a service is less expensive, only on the infrastructure side. And the last part of that is flexibility. So if I am a developer and I want to start building an application, or I'm a developer and I just want to test something, I want to play with something, especially in the distributed world, if I need to actually start, even if it's VMs in a cloud, I have to start up multiple VMs, I have to install software, I have to do this. There's definitely a benefit and flexibility of a database as a service, where you'll see in the demo, and specifically, but typically any database as a service, I could create a database within minutes. What is serverless? So, a simple thing is there's a lot of different types of serverless, but essentially what it is that a cloud provider or a software vendor is responsible for the code execution. The cloud provider dynamically allocates resources. So typically, the more throughput you put through this, whatever the service that it provides, it will actually scale up and typically scale down as needed. Typically also serverless type of code, whether it's database or APIs, it's a consumption-based charging. So the more you use it, the more you pay. The less you use it, the less you pay. So this is typically what serverless is. So this ends the kind of primer of what database is a service, and now we're going to go into an example of what a specific database as a service. And the example we're going to use is DataStax's Astra DB. So we talked a little bit about the fact that DataStax is the company behind Apache Cassandra. So what is Apache Cassandra? Apache Cassandra is a NoSQL database. It has a distributed architecture. It is by default a wide column data model. So it is very much, it's as close to a relational model it is. It's tables, rows, and columns. Apache Cassandra is known for infinite scale with very low latencies, both for reads and writes, and it's highly available with no single point of failure, right? So it's built into the database, into the Cassandra database, that you can actually have nodes fail or even data centers fail, and your database is still running. So that is very high level what Apache Cassandra is. And why do enterprises tend to use Apache Cassandra? Part of that is the scalability. I talked a little bit about the infinite scale, but reads and writes have scalar linearity as nodes are added. So if I want to double my throughput, whether it's to reads and writes, I could scale up. Very low latency. So typically we're talking about single-digit millisecond latency for writes, and similar ones for reads. The reads, it's a little bit more dependent on the queries that you're running, but that is it's very possible to have single-digit latencies for reads as well. And then it's highly available, so there's no single point of failure. Apache Cassandra by default has a share nothing architecture, which means all the nodes do exactly the same thing. So what this really causes is that people who are building real-time applications where are very low latencies are required, and scalability needs to be very important. So companies that have these what I'm going to call high growth real-time applications. So it's not only that it's a real-time application that has a lot of data and a lot of transactions, but it also is high growth. So right, I could start very small and I could get to big because I never have to worry about performance or latencies or availability as I grow. Classic examples, Apple is probably one of the biggest users in the world for Apache Cassandra. A lot of their iMessage applications is running on Apache Cassandra. Netflix is using it for their music, their video catalog. FedEx uses it for tracking. So a lot of these large real-time applications are being used, but it's not only these big organizations, it's also small organizations that want to be able to grow are using Cassandra. So what is Astra DB? So Astra DB essentially is a database as a service built on Cassandra. Obviously, we talked about the fast time to market because you'll see in the demo, we'll be able to build a database within minutes. There's zero lock-in. We could deploy on any cloud. It could run on AWS, Azure, and GCP. It's got dynamic elasticity and high availability. So there's no provisioning, right? So you actually have an endpoint, and we will scale up and scale down as needed. There's zero operational overhead. One of the things we hear a lot from the open source Cassandra users, and this is, I've had many conversations, is love the database, hate the ops, right? So they love the database because it provides all the functionality we talked about, but operating a distributed and the DevOps on a distributed database is somewhat challenging. So the fact that it has zero operational overhead is very valuable. It's true consumption-based billing, so you only pay for the actual usage that you have. In our world, the consumption is reads, writes, data transfer, and storage, right? And then there's developer velocity. So one of the things that we built in Astra on top of the open source Cassandra project is an API gateway that enable us to have very common APIs access to a NoSQL database. Sorry. So kind of give a little bit on the value prop, right? Database for high growth real-time applications. Again, we talked about the easy to use. So we also have additional APIs on top of Cassandra, like REST and GraphQL. We also have gRPC or the traditional Apache Cassandra drivers for Java or Python or C#, all those available. Elastic, there's no upfront costs, there's no upfront capacity planning. One of the things we've done in our distributed, in our Astra database and our serverless is that we actually separated the compute and storage, which enabled us to scale up and scale down. For those of you who are familiar with Cassandra know when I scale up, I actually add a node, there's a whole redistribution of the token ranges, and that can take time. The way we've done this in Astra is we actually separated that compute and storage so that we could actually scale up compute separately than storage. Again, no operations. There's a huge TCO savings in that. Global scale, we have the ability in our cloud provider to do multi-regions, so we could actually scale across those regions. Again, micro billing, again, pay for whatever you use. And again, the zero lock-in is the ability to deploy on AWS, Azure, or Google Cloud with open source Cassandra. So as far as operation, so again, zero operational burden with Astra DB. It's fully managed, highly scalable by where I would be DataStax, the Apache experts. So there's no capacity planning, there's no manual scaling, and there's no operations, and there's no installation, no configuration, no upgrades. Compaction and repair, these are Cassandra-specific operations that are constantly running in the background to optimize the performance of Cassandra. There's no replacing of damaged nodes. We have health monitoring built in, and we also manage the backup and restore operations, all of that for you. And again, this is just a recent study that we've done, that GigaOM has done on what the TCO versus open source Cassandra, self-managed open source Cassandra. And the thing that I would like to point out is like the 94% less staffing costs. So from a DevOps perspective, there's a lot less things that DevOps people have to do to manage it or to work on a distributed database. Some additional DevOps features, and these are the things that I'm going to, some things that I'm going to demonstrate to you. There's a DevOps API. We have ability to do API integration into CI/CD, and I'm going to talk about the different APIs, but we have APIs for creation, database creation, users creation of roles. All that is available. So if you want to automate a lot of tasks, you can do. We also have a Terraform provider, which manages the full cycle of the Astra serverless databases. We also have third-party metrics, so you could forward the Astra DB database and health metrics to external third-party metric system. And we are working now on an Astra CLI, and I'll show a little bit of that, which is a command line interface in a terminal to operate DataStax Astra. So the goal is to offer access to any feature that you have in the UI without necessarily having to access the interface. And now to the demo portion. Hopefully all this was interesting. And so now we're going to show some demos. So the first thing I'm going to look at is the Astra DevOps API. So this is our documentation on the DevOps API. Just look at something real here before I actually go into that, make sure. So, and this is our DevOps API. So there's different database operations that you have, like return a list of database, create a new database, find a database ID, and all those things. There's authentication. How do I authenticate to the database? Roles, users, token, access lit. We have the ability to do private links, so it actually links between your VPC and our VPC. You could bring your own keys. You could add multiple regions, and there's all different operations on the organization itself. This is kind of your account, and we'll talk about it in a little detail. So what I'm going to do now is I am going to go into Postman. So this is an example of a Postman. This is one of the APIs. So basically, I'm just using the host and the databases, and I'm going to send this request. I'm going to a demo database and a demo key, and it basically sent that. So now if I actually go into my Astra database and refresh this page, you should actually see this demo databases that's now pending. So it's starting to actually create that. So now that I'm here, what I'm going to do is I'm going to walk you through some of the features of this database. I'm going to look at a database that I have already created. It kind of tells you some overview of this database, how many read requests, how many write requests you've had, what storage and what data transfer, where it is, what's the key space. I have multiple key spaces here. I could add a region, and adding a region will enable me to have to replicate across regions. So a whole region could go down and your database is still running. This is the health check, the health monitoring that you have. So from a database perspective, it's specifically Cassandra. Really what I am interested in is know how many requests I'm having, what are the errors, what's my write latency, what's my read latency. And I could actually, this is where I talked about the way to connect to the databases. So I have different ways to actually connect to it through APIs or through drivers or through SDKs, or I could even integrate into Spark and stuff like that. I could connect to my database directly here. Again, this is a DevOps, so I'm not going to show you this too much. But on the settings side, I think it's important to note this is private endpoints for security. I could restrict IP address, and all this is available through the DevOps API. And this is where I could export the metrics that I was talking about, right? Other things from a DevOps API, I could look at the organization settings. This is what we actually have from a role management or token management. So all these things is we do token-based authentication. And this is all the things that I'm doing in the UI that I showed you previously that I can actually do from the DevOps perspective. So this is creating the database, and hopefully by now the database was created. So now I have that. It's still initializing, but we should be able to get to that as well. Also, from a DevOps perspective, we talked about the Terraform provider. So this is where we actually have a Terraform provider. It's available in GitHub, and it gives you all the different ability to do this and to use Terraform to create databases and everything like that. So hopefully that will provide you information as well. We talked a little bit about the third-party metrics. Obviously, there's documentation around that. how you export to an external system. Again, you can do that either through the portal or through the DevOps API as well. And lastly, I'm going to talk about the command line interface. So this is our Astra CLI. So there's all these different ability to actually load data and do all these different things and counts and creating a database and stuff like that. And I'm going to, and this tells you how to create a database. And last thing I'm going to do here, move this over. I am going to create a database. I already created demo, so I'm going to create demo 1, and then I'm going to create demo 1. I'm not going to wait for it. And these are just different commands. So this is completely through the command line. I'm just going to say, hey, Astra, create a database called demo. Demo is not the database. I know that it's going into keying. And let's go back to my Astra dashboard. And if I refresh this, it should show me another database that I created through the Astra CLI. And that is pending on the other one. Okay, and now to kind of summarize everything that you saw today. So the key takeaways, yeah, operation databases or scale are not necessarily easy, especially on a distributed database. Database as a service reduces the burden on DevOps significantly. And Astra DataStax, Astra DB is a great database, especially for those high growth real-time applications. I could start small and grow as needed, but you actually have all the infinite scale, the low latencies, and the fault tolerance, all with a click of a button. And you could also try it for free. Just go to astra.datastax.com. You sign up for an account. We actually give $25 a month for free if you want, and that's a fairly significant amount of resources. It's about 40 gigabytes of data and 40 million ops a month. And hopefully this was helpful. Thank you very much. And hopefully to see you on astra.datastax.com soon. Thank you.